Yesterday we focused on well-behaved functions, functions where we could tell what the behavior was, well, functions where we could tell what we expected the behavior to be, or functions whose limits we could evaluate by substitution without having any problem, like 0 over 0 or square root of a negative number. So we could try this example. Maybe some of you tried it in class. So find the limit as x approaches -1 of 2x squared minus x minus 3 all over x plus 1. Well, you will try it right now, but you will definitely find that when you substitute -1 in for x, you're going to have -1 plus 1 and a 0 in the denominator. So we have not been successful finding this limit using substitution. So if substitution yields 0 divided by 0, what we have is called an indeterminate form. The limit might very well still exist, but we haven't been successful finding it with substitution. So again, we call that an indeterminate form, and we have to dig out some algebra tools to try to rewrite the expression so that substitution will work later. So three methods that you're going to find come up very frequently when we need to do that. And the most common is what we used when we were trying to find instantaneous speed, which was we can factor and we'll be able to cancel out the denominator, which is where we had a 0. It'll leave us an expression that doesn't have a 0 in the denominator. So watch what happens when I do this. I'm going to come to here. So we're going to evaluate this limit using factoring and canceling. I'm going to scooch it all the way up here so I have lots of room. This expression. So you probably always want to try substitution, but we just tried substitution and we had a 0 divided by 0 problem. So we're going to rewrite this expression. So this limit that I had is equal to the limit as x goes to -1. Some people skip the part where they write out that limit notation, but it's not legal to do that. You've changed the value if you stop writing the limit. So don't do that. We still need that limit expression. This is going to be x plus 1 in the denominator still. I'm going to factor the numerator. I think I told you the other day that you're not going to really see very frequently that you need to factor when the leading coefficient is not 1, but here the leading coefficient is 2. We'll still be okay. That's going to be 2x, and this is going to be x. I'm going to make an assumption this might be x plus 1 because I already foreshadowed we were going to factor and cancel. And let's just double check. 2x, so this is going to be minus 3. So 2x minus 3 times x plus 1. I'm just checking my factoring by multiplying back together. Okay, so that's a correct factorization. I can, for all values of x, except for x equals -1, that expression that I had written is exactly equivalent to this limit, the same limit. But you can see here now I can cancel out that numerator and denominator. And the remaining expression is 2x minus 3. So I can now try again to use substitution. That's going to equal 2 times x when x is -1 minus 3, which makes -2 minus 3. Final answer, -5. Notice I was not able to take the limit notation off until I was using substitution in a case where substitution was not going to lead to an undefined expression. This next problem, we can attempt substitution again, but if I replace x with 16, I'm going to have 4 minus 4, 0 over 16 minus 16, again 0. So same problem. I can't use substitution, and factoring and canceling isn't going to help me here unless you're thinking of factoring in a very advanced sort of way. So another technique we might try, it's called rationalizing the numerator. You probably have some experience rationalizing a denominator. If you had a complex number, for example, or a radical expression in a denominator, you might remember multiplying top and bottom by the conjugate of the denominator. So we're going to here multiply the top and the bottom by the conjugate of the numerator. Remember the conjugate of a binomial, just say this is like, for example, x plus 3. The conjugate is the binomial x minus 3. So two binomials are conjugates if they have the same two terms but a different operator in the middle. One will have addition and one will have subtraction. So the conjugate of the numerator is square root of x plus 4. So I'm going to say, I could do this in fewer steps, but I'll show all the steps. That's the same as the limit as x approaches 16 of square root of x minus 4, x minus 16. I'm going to multiply top and bottom by the conjugate of the numerator. Now please do not actually go through and multiply those denominators together. We're going to write that expression that I get from multiplying the denominators just using multiplication. X goes to 16. That's going to equal. So in my denominator, instead of using FOIL and getting 4 multiplications, I'm just going to write x minus 16 times square root of x plus 4. You'll see why in a minute. In the numerator, that's where I'm going to multiply out. So square root of x times square root of x makes x. Square root of x times 4 is 4 square root of x minus 4 square root of x. So those middle terms cancel out. This is going to be minus 16. So when those two numerators multiply together, they're conjugates. So my middle term is going to cancel out, and I get a new numerator of x minus 16. Now you can see what happens. This is the good part. X minus 16 cancels with x minus 16. This is going to equal the limit as x goes to 16 of 1 over square root of x plus 4. Now if I substitute 16 for x, I have no problem. So I can take that limit off. This is going to be 1 over square root of 16 plus 4, which is 1 over 4 plus 4, which is 1, that's an equal sign, equals 1 over 8. Final answer. All right, one last example here. I have the limit as x approaches 0 of 1 over x plus 4 minus 1 over 4, all divided by x. This is an example of a complex fraction. It's a fraction in which either the numerator or denominator, or both, contains another fraction. So we're going to simplify this limit expression by using the same techniques you've used before to simplify complex fractions. There's definitely more than one way to go about this. But what I like to think about is I get a common denominator for the numerator, or a common denominator for whichever one part of my fraction has a fraction in it. And then once I have one fraction divided by one fraction, I'll be able to change to multiplication by the reciprocal. So that's how I simplify a fraction divided by a fraction. So the limit as x approaches 0, you could just preview. You might try to replace x with 0, but I can tell already I'm going to have a 0 in a denominator. That's how I know I'm going to need to do some algebra. This is going to be the same as the limit as x goes to 0 of, so what's my common denominator? Just above at the top part of that fraction bar. So I have two fractions. One's denominator is x plus 4. The other has denominator 4. So I'm going to make 4 times x plus 4 my common denominator, which means I'm going to have to multiply this fraction by x plus 4 over x plus 4. This fraction I'm going to have to multiply by 4 over 4. And I have a new expression. This is going to be the limit as x goes to 0. I can't take off that limit expression because I can't substitute yet because I still have a 0 and x in the denominator. This is going to be 4 over 4 times x plus 4. minus x plus 4 over x plus 4 times 4. My denominator is still x. But the good news is that numerator now has the same denominator. That sounds strange to say, but I have two fractions with like denominators in the top half of my problem, so I'm going to be able to write that as one single fraction. This is going to be the limit as x goes to 0. I still have an x in the denominator, but up here I have 4 times x plus 4 is my denominator, and up here I'm just going to combine these guys. Be very careful. This is one of the most common errors in calculus. You must distribute that subtraction sign. This is going to be 4 minus x minus 4. So that's 4. Take away x, take away 4. Simplifies to negative x. So now I'm going to have the limit as x goes to 0 of, here's my fraction bar, and I have one fraction divided by one fraction. So instead of division, I'm going to use negative x over 4 times x plus 4 times the reciprocal of the denominator would be 1 over x. Now here, I can finally do some canceling. That's a negative x cancels with a positive x to leave behind negative 1. Don't lose your negative. It's going to be a limit as x approaches 0 of negative 1 over 4 times x plus 4. Now I can make my substitution without having a 0 in the denominator. I'm going to make that a little nicer. X plus 4. I'm going to simplify by substitution. I'm going to replace the x with 0. That's going to make negative 1 over 4 times 4, which makes negative 1/16. So those are 3 techniques you might use to simplify a limit problem when substitution results in a 0 over 0 indeterminate form. So those same 3 techniques, that's factor and cancel, that's rationalize the numerator, and that's simplify a complex fraction by getting a common denominator. Those 3 techniques show up on the 3 practice problems in the back. I think I even tell you which technique to use in which problem. So try those 3 problems. You'll find that they're very similar to these 3 we just did. And there's a short textbook assignment for you too. Good luck.